Okay, so let's see how this runs in game then. So first, we need to actually create an instance of this fish spawner script. So I'm just going to hit right click in the hierarchy and then hit create empty. And I'm going to rename this object by hitting F2 and just call it spawner. And I will drag and drop this fish spawner component right there. So as you can see, the fields that we made public in the script here, these top three fields are visible in the inspector for us, and we're free to edit, like drag them around like that. So we need a fish prefab. Alright, well, where is that? So what you can do, which is click this little circle right here, and it'll bring up the dialog box, and it'll allow you to pick from your assets folder. So we want an enemy fish to spawn. So, alright, that should be everything then. Let's run it and see what happens. Alright, so now that we are instantiating it, we didn't give these fish any any position or rotation to spawn at, so they're just going to keep spawning at the same spot. If you notice, if we go hit the scene view tab, it's at the location of our spawner is where these fish are being created. Alright, so that's good progress, but we want to be able to determine the location of where they're spawning. So to do that, you can just add another field here. We can say public vector3 spawn location. Alright, so vector3, all vector3 is if we go back to the inspector here, you'll see it come up. So it gives us an x, y, and z coordinates here. So let's use these fields not really as a vector. So a vector is just going to be a position. So if you look at the position and rotation and scale object and the transform, those are all vectors up there. So it's just three floats that are in a data structure that they call vector, and they use it for like 3D math and like stuff like physics and stuff like that. We're not going to need to get into that today because of Unity's built-in physics system. We have a pretty good basis that we can start without needing to know a lot of vector math. So we have this. Let's use those just as an easy container in the inspector to create a position. So let's just say vector3 here, spawn position is equal to a new vector3, and then let's use, like, we want the x coordinate of this vector to be the x coordinate that we're going to create, but within a positive negative range of that. So we can just say random.range between the spawn location .x and between the negative spawn location .x, and that'll give us a random number between, like if we had a 3 in the x value for the spawn location, it would just say give me a random number between 3 and -3. So that's what I want to use, how I want to use that. And then for the y position, let's just use the spawn location .y, and then z, since we're in 2D, it's going to be 0. So then instantiate fish prefab, we're going to add a comma and just say spawn position here. And that's giving us an error because to use this we also need a quaternion, which is way more complex than we need to get into today, but it's basically a more efficient way than using vector3s for rotation. It's a lot faster. It has to do with calculus, stuff like that. So, but we do need one. So we just need a quaternion rotation. You can just say equal to quaternion dot identity, and then all that represents, it'll tell you if you hover over it, is the identity rotation. So that just means it's going to be level, default, whatever it is in your prefab. So just add that as a field there. Alright, so now if we go back into Unity here, and then change the values of these spawn locations. Let's see, you can see this position up here, so I want to know if I move this spawner down at a good Y position to start, like let's just say down here, so -4 be a good Y location, and then for X it's between two values, so if I move this over here we get to 9-ish. So if we just say 9, then it'll give us, our code that we just wrote will give us a value between here and then -9 over here, which seems like a good start. So now if we run, spawning along this location here, along -9 and 9, all on the same Y position. As you can see, we're still getting that problem where they're spawning on top of each other sometimes. And if you notice, they kind of spawn in the same spot and then like pop upwards. That's because the physics engine is like, oh, well, they have colliders on them and rigid bodies, so they need to get out of each other's way because these two objects are colliding in space and they can't really be inside of each other. So to solve that, we're going to set these fish to move when they start. So to do that, we can just create a new script, and you can collapse components in the inspector, by the way, just by clicking on them. There's this little arrow here, or you can just click the word. So we'll right click down in the project window and create C# script that is, let's say, set velocity on start. So just open this up, and all we want to do here is, so we have a rigid body component on this fish, and if you look in a rigid body component, there's all of these different things, and angular drag and linear drag. So this is a component, and in Unity you can get components in scripts by just simply saying get component. Alright, so this is an example of when the IntelliSense in Visual Studio doesn't really catch up. So you should be seeing like IntelliSense come up with a bunch of different options, but sometimes it doesn't catch up, and that's fine. Nothing bad happened. Just close Visual Studio or whatever editor you're using, and then double click on a script again to open it up again. And then when it's done setting up, then we should be all set to go with IntelliSense again. So here we go. We just say, yep, get component, and then there's these brackets, which is like a generic type T. So in programming, you can have generic things. So get component, and we want to get the component that is of type rigid body 2D. And then you put those parentheses after it, and then do dot, and it gives you access to all of the fields that that thing has. So what do we want to do then? We want to set its velocity. So we can just say velocity, and as you can see, because it's a 2D, velocity is a 2D vector. So we can just set it equal to a new vector 2D, and let's just, for testing purposes, give it an X value of 5 and a Y value of 5. So now on start, so right when the game starts, we're gonna try and get the rigid body 2D of this game object and set its velocity to something new. So let's just put that on our fish, add component, set velocity on start, and then hit the apply button so that it gets applied to all the other prefabs as well. And then hit play, and now they're spawning and going in that direction. So 5, the velocity is set to 5, 5, so they're going to be moving in a diagonal direction. Alright, so that's what we want, but we want to be able to control and kind of add a little bit of randomization to that. So I'm just going to make four fields and just say public float min x value, public float max x value, and then public float min y value, public float max y value. And then here when we create this vector, we can just say random.range again between the minimum x value and the max x value for the x for that, and then say random.range dot range in between the min y value and the max y value. So this is a little bit cramped on this line, so I'll just do this. Just hit enter there, enter there. Looks a little bit better, a little bit more readable. Yeah. So now, let's see, we should get a couple fields pop up. Let's say min x value between -5 and 5, and a y value between, we always want these fish to be moving upwards, so we can just say, let's go with 5 and maybe something a little lower, 3 and 5 maybe. And hit the apply button, and if you notice right here, if I change this value, it bolds that field. And so that is telling you if this is a prefab and you have unapplied changes. So just hit the apply button, and now they're going to be going in all different directions like that. So that's a little bit more exciting gameplay. So there you go. And now those fish are spawning. Let's make it a little bit more exciting to click on them by adding a custom mouse cursor. So instead of just this regular mouse from Windows being here when I click, I want something a little bit more fun. So we can go project settings, player, and then this default cursor here takes a 2D texture. So let's scroll through some of these and see which one we want. How about, is there like a cross or something, an X maybe? X, HUD X, look at that, perfect. That looks like it could be a little bit more fun. So let me hit play. Yeah, I think that looks pretty good, matches the art style. Alright, so now if we let this run and play, notice over here in the inspector, we're creating those 3 objects, but if I just go in the scene view, they're here forever. Like there's all these little fishies being created, and they're never getting destroyed. So that's not going to be good for our performance. And we can see that if we go into Window and then Profiler. If you click on that and just drag it in a tab down here, you can see this is the performance and the CPU usage and memory usage and rendering, stuff like that. So you can see these spikes of where these fish are being created like that right there. That's no good. And down in the memory, there's these, like, this is happening every time we create fish there. So those little bumps, those purple spikes there. That's not what we want. See, that's GC allocated. That stands for garbage collector. So, and that's a pretty common problem in Unity and games in general, is dealing with memory. It's really important and a challenge to deal with memory in the right way. So what I'm going to do is just tell these fish, instead of staying alive forever and ever and ever, just get destroyed after a certain amount of time. So to do that, we're just going to add a script here and say destroy after time. This is going to be simple enough. I'm going to make this small method here called kill me, because these are really sad fish. You know, they don't want to live after a certain amount of time, because fish have short lifespans, you know. So make it a lifetime variable of like 4 defaulted to, and we'll just say right here in the start method we can say invoke, and Visual Studio is doing that thing again, but if we just say invoke and then the name of the method as a string, so kill me, and then comma our lifetime, what that's going to do is right on start it'll tell the game, hey, in this amount of time, after our lifetime, call this method called kill me, and then that would just be destroy this game object. Well, IntelliSense is actually messing me up right now because it's not fully loaded. We just backspace there. Okay, that looks good. I'm going to close Visual Studio because it's doing that weird thing again. And then add that component to our fish. So call it destroy after time. And hit apply. So now if I hit run and I look out in the scene view here, see these fish are disappearing after a certain amount of time. So after they get off the screen, we don't care about them anymore. We can just get rid of them, and then we don't have to keep track of their physics or anything like that. Alright, so I think this is looking good, but I think that our spawner maybe needs to be a little bit faster, and maybe a little bit more fish. So, well, not 20, maybe 10. Okay. And then time between waves. Oh, well, 10 fish. 2 is probably good, but that looks kind of stuttery, so maybe less fish. And shorter time between the waves is like 6. Okay, that's a little bit more consistent looking, I think. And then maybe if we spawn them down a little bit lower, below that parallax layer there, then they'll come out from behind it, and that looks pretty nice. But then you notice I just made a bunch of changes while the game was running. So if I were to end this right now, this would go back to what it was before we started. So what I'm going to do is right click and hit copy, and then turn the game off, and you see this went back to those old values that we had. But you can just right click and hit paste component values, and it'll go back to what we had. Okay, so now we have our fish spawning and going in random directions, and we can destroy them. So now we're at a point where we really just want to maybe add a score in here. So I'll create a new script called scoreboard and open it up in Visual Studio. And this is only one way to keep track of score. What I'm going to do is make just a public static int and then call it score. And what the static keyword says is that you can have multiple instances of the scoreboard class, but this integer here that's static is going to be consistent across all of them. So that's easy enough. It's not the best way of keeping track of score, but because this is such a simple little demo here, that's all we really need. So let's test this out here. And actually, instead of doing that, let's make that private. A little bit of encapsulation here, and then do public static int. I'm going to rename this one here to be _score, and call this score. So this is what's called a getter. So you can just say get and then hit return _score. So all this variable does is they're called getters and setters, accessors, modifiers. There's a bunch of different names for them. But all they do is allow you to get and set the value of this variable, and that's their entire purpose. So score equals value, and now we can access this score variable anywhere. So we want to increment the score when we click on stuff. So whenever we destroy a game object, say scoreboard.score ++, and then that's just shorthand for saying plus equals 1. Instead, we can just say ++. Alright, so now inside of the set value, you can also do other stuff here. If we had we could set some UI elements here, or what I'm going to do is just debug.log scored, and then plus the current score, so score, and because it's an integer, you have to do .toString, and that should just print out to the console whenever we do that. So, but we still need to make an instance of that class. So if I just create an empty here and just call it score, add component, scoreboard, that should be all we need to do there. And we can hit play. If we look at our console, scored 1, 2, 3, etc. So now let's add some UI to this to represent that score to this player. So let's just do create UI text. Let's rename this text to current score. You don't see it anywhere, so if you just find it and hit F2, see it's down at the bottom there. We don't want that. So one way to do it would just be to go in the inspector for this object, and you can change the position of it. But a little bit better way to do it, one that scales better with different size screens and stuff, is to use anchor points, anchor presets. So if you click here and then go and do this, you're changing like the anchor point, like in like a web document or something like that, change the anchor. So if you do this and then hold Alt and Shift at the same time, you can change the actual position of this element. So I'm going to pick the top center, and as you see it left, so I'll just focus in on it. And now it's at the top and the center of our screen. I'll center this text and just say 1 as a test value. Alright, it's a little blurry there, so I'll just turn up that. It's super blurry. I think it's because of the font that we're using, but that's okay. Well, another thing you can do is just click this best fit here. So it'll pick the thing that fits the size of this box here. So this little UI element has this box that's saying how much space it actually takes up. So then if we want to change that, we just go into scoreboard and we want to set some UI. So we need a reference to that. So we can just say public Unity Engine .ui.text, because that's the type of UI that is, and then say scoreboard text. And then we can set it in here by scoreboard text.text equals underscore score dot toString. But we'll see here that doesn't work because it's not in the same, it's not static. So what I'll do, just as a quick fix, is private static, and then that'll get rid of that error. And then on start, we can set that scoreboard text equal to get component Unity Engine .ui.text, and then that'll get rid of those errors. And as you see here, I'm using this Unity Engine .ui. If you don't want to do that, you can go up here and just say using Unity Engine .ui, and then that, see, that got grayed out because it's not necessary anymore. But I don't need the entire UI engine from this, so I'm just going to keep it like that. Alright, so now if we're getting this component, then we're going to need the scoreboard component to be on something that has that to get it, right? So if we just move the score script onto that, then what we should see happening is as we increment, the text changes. So that's good, but that font is really ugly. I really don't like that. So what I'm going to do is just go onto Google real quick and type in Google, not Google Types, whoops, Google Fonts, if I can type. And then there's this first link here, and these are all fonts that you're allowed to download and use. Let's just use this Roboto one by adding that. And then this button, download, gives you a little zip, show in folder, and now I will just right click and hit use 7-zip to extract here. And that's going to give me a bunch of .ttf files, which stands for a font. And you can just drag and drop that into a new folder that I will call fonts, so that it's nice and organized. I'll just go like that, and that imports all those fonts. Now we can use those anywhere in Unity. So this text, the font option here, I'll pick Roboto Black. That looks a little bit better, but think it'd probably look better if it was down a little bit more, and maybe if it had a shadow on it. So if you want to add UI element like shadows like that kind of thing, just type in shadow, and you can see now it's got like that nice little black background. It's a little dark, so maybe tone it down a little bit. Move it to the right one. Alright, that's looking good. So now, click on all these guys, you know, we're scoring points. Alright, I'm having fun. This is good. I think it might be a little bit better if this fish here had animation to them. So to do that, pretty sure there's two different little options for this fish guy. So if you're looking at it, it looks like the tail's a little bit different on one of these sprites than the other, so that it's like swinging its tail back and forth. So let's just add that animation real quick. So if we just do add component animator, and then go to window animation, which is right here. I'm a little blind for a second. And then bring that tab here. We have our fish selected. Hit create. And we'll call it swim. And we'll save it in our assets folder, art. Make a new folder called anim for animations. And save that. So an easy way to do that is I'm just going to split these back windows here. Make that a little bit smaller. And then I'll just drag those two there. So now all this is doing is switching between the sprites, and as you can see, you can scrub the timeline, and if you look in the game view, he's moving his tail back and forth. So if we just hit play here, it's going to look really weird, and that is because we need another sprite to go back to the beginning so that we have a nice little animation loop instead of just something that switches back and forth uselessly. So now if we hit play, get a nice little swim animation. It's not like super fantastic, but you know, it looks pretty good, I think. So I'm going to apply those changes to the fish here. And just got to save that animation, fish, apply. Now when I hit play, all my little fishies are swimming with their tails. I think they're moving a little bit too fast here. So let's go to our spawner and change their, oh nope, that's on the fish actually, their set velocity on start script. Change their Y, change all these values down a little bit. So -3, 3, max Y value down to maybe 4. Yeah. It's still a little bit fast. So, oh, that's because I didn't hit the apply button. See, that's where it'll get you. You always got to pay attention to what you're applying. Yeah, that looks better. All right, so now you can click on these guys and go fishing. So from here, you can take this code that I've written for you guys and add a bunch of mechanics in. Definitely would encourage you to look into some more complex things you can do with some vector math and stuff like that. Check out some other art assets. A great tool for us as Unity developers is the asset store. So if you can access it in Unity itself, and this is, you can just search anything. There's a bunch of different stuff. There's featured content. If you're a coder, you're not great at art, then you can just go into the 3D model section and pick characters, and there's a bunch of character models for you. Some of them cost money, but you can filter them out with just the free button. And there's a lot of good ones on there. But make sure that you always credit the artist and stuff like that. Conform to whatever licenses they have on there. Okay, so I think that's going to be it for today's demo. Thanks. See you soon.